All right, so moving on to section 3.3, we're going to now start discussing algorithmic complexity. So algorithmic complexity is looking at algorithms. I'm going to take the algorithms that we went over in section 3.1, the linear and binary search algorithms, and then I'm also going to discuss the bubble sort, which I didn't have time to get to in class, but that I asked everybody to look at on their own. So we're going to go over those algorithms and we're going to analyze their complexity. Now, there's two ways to analyze complexities, two common ways to analyze complexity of algorithms. One of them is time complexity and the other one is space complexity. So time complexity has to do with measuring basically how much time it will take an algorithm to complete and like find the solution to a problem. Now that is going to depend on your hardware, right? So it's going to depend on how fast your processor is and that sort of thing. We're not going to worry about that sort of thing. Like we're not going to worry about the actual seconds, like how long it's actually going to take to compute it. We're more concerned with how many steps it's going to take. So the way we generally measure algorithmic complexity is by counting the number of what are called constant time operations. So that would be operations that don't increase with the amount of time they take as you increase the size of the input to the algorithm. A lot of the algorithms we're working with deal with lists. So we're going to use the length of the list, which is usually represented by an integer n, as the size of our input. But some other algorithms might be things that are computed just based on like a number. And so say you give it like an integer as an input, then the size of that input might be maybe the number of the number of decimal places or something in the binary representation of that number. That might be our like size of input. But for us, it's going to be almost always the length of the list. So we want to measure constant time complexity, the number of constant time operations involved. This is going to be a function of the size of the input. Now, what are the constant time operations that we're counting? Examples of constant time operations. One example is a comparison. Oops. So this would be any time you compare two numbers. So like whether that is with a less than or less than or equal to, an equal to, or a not equal to, something like that. It's checking one of those comparisons. That would be a constant time operation. An assignment statement is a constant time operation. So like when you say I set that equal to 1, or when you say like location set that equal to n, something like that. Those are assignment statements. Okay, things like returns, accesses, indexing, that sort of thing. When you say, hey, take this list element and look at AI, look at the ith element of that list when you're accessing a list, or when you're reindexing a list, or when you're returning an element to to the value of function. Those kind of things are constant time operations. And then we have like math operations. When you are adding, when you're multiplying, when you're dividing, and when you're subtracting, or when you're even exponentiation, which exponentiation is a little bit complicated. I don't really understand this, but Andrew was telling me that exponentiation isn't necessarily always a constant time operation, but it's often treated as if it is when we're analyzing complexity, that kind of thing. So these are the sort of things that are constant time operations. And when we are analyzing complexity, we usually limit our analysis to certain types of operations. So like in the homework problems, you'll often see count, just in terms of like additions and multiplications, right? Just how many of those are there? You might see, you might be asked about comparisons. You might be asked to count the comparisons specifically, or maybe the comparisons and the additions. What I'm going to do is, in my examples today, I'm going to sort of be as thorough as I can, and I'm going to count assignments. I'm going to count comparisons. I'm going to count math operations. I'm not going to bother counting returns and accessing and indexing, that kind of thing. I'm not going to count those, but I'll do all the other ones. Okay, and this will be a way of analyzing in terms of a certain type of complexity It turns out that a lot of times we don't care that much about the the comparisons used in a loop, or we don't care about indexing. We don't care about assigning the value of an index. A lot of times we ignore the minor parts and just focus on maybe the the sort of like the more significant portions of the algorithm. But I'll explain that a little more as we go. So I should mention one more thing about this before we get started, and that is that there are two types of complexity. There's like worst case, and there's average case. I don't know why I spell worst with an E. It's like a sausage. Sorry, my bad. Average case complexity. So either worst case or average case. Now, worst case complexity is what I'm going to be focusing on. So that would be thinking, what is the longest period of time that this could take? What's the maximum number of operations that this could take if everything was like the most challenging it could be? If you don't find the element you're looking for until the very last chance, that sort of thing. What's the maximum length of time it could take? Average case complexity is a little more complicated, and I'm not going to dive into that too much. So if you want to, you can read about this a little bit in the section, but I'm not gonna really get into that. So space complexity and average case complexity are things I'm not going to go into. There's also some stuff near the end of this section about P and NP, which actually one of our teams is going to give a presentation on. So that team is going to read up on that stuff, and then do some further research on P, like what are called the complexity classes, P, NP, and then the other complexity classes beyond those. So that stuff I'm not going to discuss in these videos either. All right, so I think that's all I wanted to say just as a preface to this section. So now let's dive in and look at an example.